Okay, first I want to thank you for participating in this little research experiment.
You're welcome.
I'm going to ask you three problems and questions and about problems, and then you can talk to me about how you would solve them. And feel free to write down your solutions or any notes or things that you would do or need in order to solve the problem.
Okay.
All right? The refund problem is our first problem. In some states, uh, a deposit is charged on aluminum pop cans and is refunded to the consumer when they return the cans. In New York, the deposit is 5 cents per can. First question, what would be the refund in New York for returning 6 cans?
Well, if it's 5 cents each can, I would multiply 5 cents times 6, and I would get 30 cents. So it would be 30 cents for each 6 cans.
Okay. Describe how the store owner would figure the amount of refund for any number of returned cans. Like, what process would they go through? Just describe that process.
Multiplication. If it's 5 cents, he can count the cans and multiply it by. He can count how many cans there are and multiply it by 5 cents. 5 cents.
Okay. If R represents the amount of the refund and C represents the number of cans returned, write an equation for the amount of refund.
Number of cans. So, can you repeat it again? I'm sorry.
Okay, so R is the refund amount,
For each can or the total?
the total,
The total. Okay.
okay? And C is the number of cans. So write an equation that would tell me for the number of cans returned what the total refund would be.
Okay, so I would do the number of cans. I would do C times how much each can is equals R.
How much is each can?
5 cents.
Okay, so yeah.
I would do 5 cents times the number of cans equals the amount of refund.
Okay, is that a decimal?
0.5, yeah.
Okay. All right. Okay, very good.
0.05.
Okay. Now use your equation to find out how many cans you would have to return to get a refund of $3.
Okay. So, what I would do is, how do I equation? I would actually divide 3. See how many 5 cent goes into $3. So that's what I would do.
Okay, now you're working intuitively. The question says use your equation
Oh my. Okay.
to determine how many cans you would need to return if the refund was $3.
Okay. So in place of R, I would put $3.
Well, don't erase your equation. Just write a new equation.
Okay. So below, I will put $3 where R is in my equation. Then I will put 5 cents back and let's see. And so I could get C, I will divide each side by 5 cents. And I will get 60 cans.
Okay.
60 cans.
All right, that seemed pretty easy for you. How much would your refund be if you had 100 cans?
100 cans, I will put, for a new equation, I will put 100 times 55 cents equals R. So I will multiply 100 times 0.05 and I will get $5.
Okay. Makes sense. All right, let's go to the next problem. Okay. The next problem is called the border problem. The border problem, and I'm going to give you a grid. Okay. All right, you see that? All right, so all the questions will be associated with that grid. Now, without counting, how would you, how could you determine the number of squares that are on the border of a 5x5 grid? So I've shown you a 5x5 grid, and you can't count, but you do know that it's a 5x5.
Okay.
All right, so without counting, what math would you do to determine the number of squares just on the border?
I would find, I would use the area for a square, and, no, not all of it. Let me see. I would use, the area for a square, which is, I forgot the area of the square. Length times width, or is that
The area of the whole grid?
Mm-hmm.
Okay, now you're only interested in the number on the border.
So just the,
Mhm.
okay, so,
I'm not saying that the way you've started is right or wrong. I just want to make sure you're clear what we're asking, because there could be multiple ways of solving that.
okay, well, I would first find the area of the whole square,
Okay.
and then I would subtract it by how many squares there are on the border. So 5, 10, 15, 20. So I would subtract that by 20 once I get my full area.
All right, write that down for me. Write down what you would do. The area. You said you would find the area. How would you do that?
Area is length times width. The area is length times width, and the length is 5. The width is 5. So that would give me 25.
Okay.
The whole square. Then I would subtract that by 20. So that means I have 5 inside, which is not right. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay, you subtracted 20. Why did you subtract 20? How'd you get 20?
Because that's how many squares are on the outside.
Okay, that's the question is how many squares are on the outside?
Oh. Okay. Well, I would do the same thing, but I would subtract how many squares are on the inside instead to get the number on the outside.
Okay, so how many squares are on the inside?
It's 9.
Okay,
So,
so go ahead and continue your process.
I would do 25 minus 9, which is 16.
Okay, earlier you wrote 20.
Mm-hmm.
Is it 16 or is it 20?
Great question.
I'm sorry, what did you say?
Oh, nothing. I said it's a great question.
Okay.
25 minus 9. I don't know how I got that. I think that... that would be the area. I think I used the right formula for the area.
What would be the area?
What, length times width, the formula for the area.
Yeah, that gave you the 25. I'm questioning the 20. How did you get the 20?
Count the squares.
No, you didn't count the square.
What did I do?
Right? I said without counting the squares. You actually did, if you remember, you actually did a mathematical operation to get the 20.
I multiplied. Maybe I forgot what I did. 5, 10, multiplied 5 by 3, 4.
By 4, okay. And that produced 20.
Yes.
But then your second approach was to take the area of the whole grid and subtract the area of the interior, and that gave you 16.
Yes.
So one of those methods has a flaw.
Yes.
Which one do you think has the flaw?
The length times width, the area for the square.
Okay, you're saying length time width. That's 5 by 5. That produces the 25.
Mm-hmm.
So we're not talking about length time width. We're talking about how you got the 20.
Trying to find. Oh, I multiplied 5 times
Times
4.
Okay, why 4?
Because that's how many sets of 5s there were. 6 of, yeah, sets of 5.
Okay. But you said you think that's the error, so you think the 16 is the right answer.
No, I think 20 is the right answer.
You do. You think 20 is the right answer.
Mm-hmm.
Okay. So what do you think is wrong with the process for the 16?
I'm not sure. Well, I still think that the length times width was in the right area. So if
You think it was or wasn't?
wasn't the right area.
5 times 5?
Well, I don't know if the length times width was the right formula, I should say, for finding the area of a square. But I think it is length times width.
So how many squares do you have along this side?
5,
And how many squares do you have in each row?
5,
So how would you get that area?
5 times 5.
So you
it
you
is
have
right.
faith in 5 by 5?
Yes.
Right. Again, the question is not about the 5 by 5. The question is about how you chose to get the count on the border.
Okay.
And one method produced 20, the other method produced 16.
Well, if I see that each row has 5,
On the border?
yes, on the border.
Okay.
But if I go down this way, if I say 5, it's not really 5. It's actually 4. Because I already used the square that's in this row, so I can't use it again.
Okay, and then what happens when you go?
It's the same thing. I can't use this square. It's only 4. Same thing for up here. So that's probably why I got...
Well, let me show you. So you said 5 here, right?
Mm-hmm.
And then you said 4 here,
Mm-hmm.
and then 4 here. How many in the last edge?
4. 5. It's 5. I started off with 5.
Oh, okay. I'm sorry. I started you here. So you start off with 5.
5.
Then what?
And
How
then
many?
4.
And then
4.
how many on the last side?
3.
3. Okay. See, I didn't hear that the first time. So which of these answers is right? The 20 or the 16?
I think the 16 is right.
Okay, circle that for me.
Okay.
All right. Can you use your method to determine the number of border squares on a 100 by 100? Clearly, we don't have 100 by 100, and you can't draw it. But can you take this approach to determine the number of squares on the border of a 100 by 100?
I would... 100 by 100. The area, which would be 100 times 100, which would be 10,000.
Okay, write it down. Write down your process.
The area equals 10,000. And
So then what did you do?
I subtracted by how many squares there were in the inside.
How are you going to get that for the 100 by 100 case?
I don't know. If...
So you got this inside here,
Mm-hmm.
right? And so how could you determine the dimensions? How did you determine the dimensions of the inside?
Just counted them.
Okay. Oh, so you just counted them?
Mm-hmm.
All right. Well, how could you determine it without counting them?
A formula, I'm guessing.
Well, how many?
Well, I would find the perimeter of the square and then subtract it by the area. Well, the area is subtracted by the perimeter.
Okay. What were the dimensions of the whole thing?
5 by 5.
And what were the dimensions of the
3 by 3.
Okay. Is there a relationship there?
Yeah, 5 to 3 relationship. I don't know.
You know, you went from a 5 by 5 down to 3 by 3.
So
Is there a relationship
2
that can be applied to the 100 by 100?
Yes. So I could subtract 10,000 by 20. I'm guessing 20, and maybe get 9,000.
Well,
980.
let me back you up. Because you're using 10,000 and we use 5 by 5 and 3 by 3.
Mm-hmm.
Right, so we just use single dimensions, 5 by 5, 3 by 3. And so is there a relationship between 5 by 5 and 3 by 3 that you could apply to 100 by 100?
5 by 5, 2.
What would in other words, if the outside was 100 by 100, what would be the dimensions of the inside?
70 by 70?
How are you getting that?
No, not 70 by 70, 88 by 80. Because it's subtracted, well, like it's subtracted by like that 2, but I wouldn't say 2
Okay.
because it's not in every case, it would be 2.
So how many layers on the outside do you have to lose to get to the inside?
1.
So the outside of the first one was what dimension?
5,
But the inside dimension was,
3,
so how do you get from 5 to 3?
subtracted by 2.
So if you had 100 along this side, how long would it be on the inside?
98.
Okay, all right. So what would be the dimensions of the inside?
98 by 98.
So can you use this process that you did with the 5 by 5 to do a 100 by 100 case?
Yes.
Show me what that would look like.
So I will find the area, subtract the area by, subtract the area by 2. And
Is that what you did here? To go from 5 to 3, were those
No.
areas?
not the area, subtract the area by what's in here. The 98 by 98.
Okay, so do that for me and show me what you would get.
So 98 by 98. So I subtracted by 9,604.
Okay, and so what would that give you for the number of squares on the border?
It will give me 396.
Okay. All right, circle that answer. And just identify where your how you got 9604. How'd you get 10,000?
Oh, squared 100.
So how did you get 9604?
Oh, subtracted.
What's the interior? What's the dimensions of?
98 by 98.
Okay, so that's how you got that number. Just identify that on the paper. Okay. All right, so I'm going to turn up the heat a little bit on you. Now that you analyze the 5 by 5 and the 100 by 100 grid, can you describe how you would find the number of squares on the border of any size grid n by n?
Well, I would first find the area.
Which would be what?
And what's this?
We're dealing with n now, n by n. In this case, this was a 5 by 5. This was a 100 by 100. So we now need an n by n.
Okay, so
So your area, what would your area be?
the area will equal n times n, well, n squared.
Okay. Then what would you do?
and that will equal my area. And then I would do the area subtracted by,
Is it area? Because you
Oh.
told me before
I would subtract,
that it was just this dimension.
the n by 2. So it'll
Okay.
be n minus 2, and
And,
that
and
will,
then what'd you do with that?
I squared that.
Okay, show me that.
N minus 2. I don't know. N minus,
Just indicate how it would look. All right. Then what did you do?
I solved,
What math did you do to get this 396?
subtracted the area of n squared minus n minus 2 squared.
Okay, write all of that into one equation.
Okay, so
You have the two pieces. You said you would subtract them. I'm just saying write all of that on one line.
so it'll be n squared. No,
Well, okay, what did you do here?
n squared
Oh, okay. And then what did you subtract?
minus n minus 2 squared,
Okay.
and then
And that would give you what? That would give you your answer, right?
yeah,
Okay, so just put equals b there so that we know that b is the border, number of border. Okay? All right, circle that for me. You think that will work in every case?
yes,
Okay. All right, so if n represents the number of squares along one edge of the grid, okay, and b represents the number of squares on the border, can you write an equation that calculates the number of squares in the border of an n by n grid for any value of n? It looks like that's what you have here. So now use that to determine the size of a grid that has 76 squares on the inside. No, I'm sorry, on its border. 76 squares is only on the border. So use your equation to determine then what the size of the grid is. The n by n. What is your n?
so it's 76 like how it was like 5 by 5
It's 76 on the border. It's
all together. Okay. Oh,
so use your equation now to find n.
n squared n minus 2 squared. Okay. Take the square root of
Square root?
distribute 2.
No, that's a power.
Squared 2.
Okay, how would you square this quantity?
Give each number, well, give each number in 2.
No.
Power 2.
No, that's if it was a multiple. If it was a multiple in there. This is subtraction, right? So that's a binomial. How do you square a binomial?
Foil it.
Okay. Go ahead.
So I will do it first times first, which is n squared, then outside by outside, which is negative 2n, inside by inside, which is negative 2n, and last times last, which is 4, positive 4.
All right, so go ahead and
And
finish
then-
your equation.
Bring down my n squared and add like terms.
Now, how would you find n from there?
I have to still add my like terms. So
I'm sorry, I can't hear
I
you.
still have to add my like terms. So n squared minus n squared will cancel out.
All right.
And then I have negative 2n minus 2n, which is 4n. And then 4n plus 4 equals 76. So I subtract 4 on both sides. And 4n equals 72. Divide each side by 4. And n will equal, I think, 12. 18.
Okay. All right. Very good. Okay, we have one more problem. It's called the car wash problem. Okay? Metro Car Sales hires washers to wash the cars in their lot. Okay? The manager knows that 36 washers can wash all of his cars in 1 hour.
Okay.
Okay, 36 washers, it can wash all of his cars in 1 hour. Now, if only 18 or half as many washers worked, how long would it take them to wash all the cars?
Okay. It will take them 30 minutes.
So you have half as many people, and they're faster?
No, they're not.
Right. You got a big team here, and they take how long?
36 takes an hour, and 18 takes 30 minutes. And I got that by dividing how many washers I started off with by 2. And what you do on one side, you have to do on the other. So I divided 1 hour divided by 2.
Okay. Does it seem to make sense that half as many people would get done faster?
No.
You want to rethink it?
No. Because 30 minutes isn't as fast as an hour.
It is faster. If you get done with the cars in 30 minutes, right?
Mm-hmm.
Did you take longer or shorter amount of time than an hour?
Shorter.
But you have half as many people. So you're saying if I don't have as many workers, they'll get done faster.
Yeah.
Really?
Oh, I see what you're saying.
Can't hear you.
I see what you're saying now.
All right, so you want to rethink that?
Mm-hmm. Okay, I will multiply it by 2.
Okay, so what would that show me that?
So I do 36 times 2. And,
Why 36 times 2? You just explain to me your logic.
oh no, it went down to 18. I would do an hour times 2, so it will take them 2 hours.
Okay. Where did the 2 come from?
Because
Show me that though, the hour times
Oh.
2 that you just talked about.
1 hour times 2 is 2 hours.
Okay. How did you get this? Because obviously you're taking the original time, right? And you're changing it. So how did you get 2?
I got 2 by dividing 36. 36 divided by 18.
Okay, so go on and put that down and just kind of clarify where the 2 came from. Okay. All right. What if, how long would it take if there were 72 washers?
72, 3 hours.
And what are you basing that on?
36 times 2.
Well, wait, what did you do the first time?
I did 18 times 2.
No, but how did you get the 2?
Oh, I divided 36 divided by 18.
And 36 represents the,
Original,
and the 18 represents,
the new,
so what does the 72 represent in this case?
the new.
So how would you use that?
Well, 36 divided by 72.
Okay, keep going.
So
And what would you do with that?
36 divided by 72 will get me, half an hour.
Okay. Now, after you divide it, in the first case, what did you do with that answer?
I multiply it by how many hours? I multiply it by an hour.
Okay. So are you so is that what you did here? Is that how you got a half hour?
Yes.
Okay. All right. So does it make sense that you have twice as many workers and they're getting it done in half the time?
Yes.
Okay. What if you had 9 washers?
9, I will do 36 divided by 9.
All right, show me that.
36 divided by 9 is 4. So it'll take 4 hours.
4 hours, okay. Describe how the manager then, using this method, could find out how many hours it would take to wash the cars for any size group.
Take take the original washers, the 36, and divide it by how many washers there are now.
Okay, can you just write it down, just in words?
So, write down in words.
Yeah,
Okay.
just a brief sentence on what you just said.
So, take 36 and divide it by the original, the new amount of workers.
Okay. Okay, write an equation for finding the number of hours it takes to wash the cars if you know the number of washers. Use H to represent the number of hours it takes and S to represent the number of washers.
Okay, so I will do 36 divided by S equals H.
Okay. Use now that equation to find how long it would take 10 washers to wash all the cars.
36 divided by 10 equals 3.6.
All right. So it would take 3.6 what?
Hours.
Hours. Okay. All right. Looks good. Just want to thank you again for participating, and hope all goes well with you in your high school math career.
Thank you.
All right.